Right. I might stand up a little bit. Let me know. Maybe it won't record if I stand up.
Make sure you can hear yourself.
Hello. There we go. Cool. So I'm Peter McKee. I'm a senior engineering manager, formerly at Docker. It's sad to say. We were purchased by a separate company just a couple weeks ago. But yeah, so I run the customer success engineering team. We're a small team, but we handle enterprise portal, different things. But anyways, we write a lot of stuff in Node, JavaScript, full stack JavaScript, of course in containers, all that good stuff. Anyway, so wanted to talk a little bit tonight to you guys about code construction and how to kind of think about it. And so this kind of spurred me on when I was talking to some colleagues and some people in the industry, and it's been percolating in my mind for a little bit. You know, what is a senior engineer and what's a junior engineer? And how do you move from a junior engineer to a senior engineer? What does that look like, right? Is it code? Is it number of years in the industry? You know, what does that actually mean? If you look at a lot of job posts out there, right? Everybody's looking for a senior, right? Everybody needs to be a senior. It's kind of like if you've been employed for a year, now you're a senior engineer. So, you know, and then you start to get into what's poorly written code and what's well-written code. You know, it's a lot like art. I can't maybe describe it to you, but I know what it is when you look at it, right? So, and that happens a lot when we do code reviews. You might not be able to articulate what you're looking at and what's wrong, but you kind of know inherently things don't seem right. And so, yeah, so when I kind of explore that, how do you go from a junior engineer, and even as a senior engineer, how do you think about how you create code? So yeah, so what is good code is the question. I think the foundation of that is cohesion and coupling. Has anybody heard these terms before? Yeah, I did not make up these terms, obviously. I stole them from others, some other smart computer science folks. But I like to call it the art and science of, I scratched out rock star there, it annoys me. Anyways, becoming a better engineer, right? And there's an art and a science to creating code. We're gonna talk a little bit about that too. But I'm just starting off some definitions, coupling and cohesion. And I'm going really fast. You write these slides out, and you don't usually go this fast. Anyways, so ask questions if you have any. But so coupling and cohesion are the foundation of good code. All frameworks, all design patterns. Anybody read The Gang of Four? You've heard of that book, right? It's a classic code patterns book, thick book. I think it's a lot of Java examples, C++ examples, but there's a lot of patterns in there on how to construct code. And if you really look at those are all at the foundation of them. They deal with cohesion and coupling. And so cohesion and coupling kind of contrast each other. So you want to have loosely coupled and highly cohesive code. So coupling is you know, code sticking together, and actually it's on the next slide. So when couple is tightly coupled, right? It's two systems that are tightly coupled together. They're hard to break apart. You get leaky abstractions, right? Has anybody heard of this term, right? So yeah, so down inside of a module, when you're using a module, you kind of have to know how it works internally to really use it well. And so that abstraction is being leaked out. Right? Has anybody used Angular 1 with the dollar signs everywhere, right? And had to understand watches in the update cycle. Those are leaky abstractions, right? The core of the engine has popped up, right? And it isn't a matter of just understanding how the framework works, right? You have to know some of the internals, right, to understand how it fully works, right? So you get some leaky abstractions. So things are tightly coupled together. So you want loosely coupled code. And then you look at cohesion, and cohesion is a relationship between modules and even functions, right? But pieces of your code base. You want to have things that should be, that fit well together, should be closely together, right? So if you think about, let's say logging, right? A logging library. You want things in the logging library that deal with logging, right? So formatting of the logging messages, setting the debugging, the level of logging that will be actually logged, right? But you don't want to have database code, database access code, right? You don't want to have even file access code, right? Those things want to be abstracted away. They should be in their own modules that the logging module might use, and they want to be loosely coupled, right? So a lot of logging systems now, except for the one that I wrote lately, it is loosely coupled, right? So you're able to pull out you can say, hey, I want to input into a logger that will log to the database, or I want to replace that with a rolling file logger, right? Or I want to replace that with console log, right? And so those are loosely coupled. The logging system is highly cohesive. Everything that deals with a logging system stays in the logging system. Does that make sense? Any questions? So in summary, you want loosely coupled, highly cohesive code. And I think it's on the next slide. Yeah, so kind of jumping into the art and science of software engineering. Does anybody ever talk about writing code as art? Does anybody think about that? Yeah, yeah. You know, and I kind of look at it through these three levels. They kind of built. Now this isn't a perfect model, and these aren't clear lines that I've draw between these three kind of disciplines. You know, they blur, right? So bear with me. No one beat me up on my definition of computer science or software engineering. But I just wanted to give the idea of, you know, how these things build on each other. And so in computer science, right, it's really focused on the science, right? So theoretical computations, algorithms, big O notation. You're going to be testing, investigating, right? And there is going to be some system thoughts, right? So distributed systems, you know, but you're really sticking around that theory, right? Data structures, searching algorithms, you know, indexing in databases, those type of things, right? You really focus on that. So if you look at a computer science curriculum, right, you're going to talk about, you're going to have an algorithms class, you're going to have you know, you're going to have very focused computer science classes, and those are fantastic, right? And then you kind of move into software engineering, and what we do generally day to day is we take computer science theories, patterns, and practices, and form our own patterns and practices and build software with it, right? You know, you don't normally write a search algorithm daily, right? You know, you're going to use a library, although you might write it in your interview question, depending on where you're getting interviewed, right? And those are good principles, and these guys are laughing over here because I know that we weren't together. I beat them up, beat interviews about it. But anyways, right, you're not writing algorithms, search algorithms every day. You're not writing indexing algorithms for a SQL database, right? Binary trees, those type of things, right? But you're using them, and you're taking those and you're putting them together and you're building larger systems, right? So really focusing on patterns and practices. In other engineering fields, right, it's a lot more physical world, right? So you're plugging systems together, clear separation. So you know, when you plug in your video card into your computer, you can see things that are tightly cohesive, right? Everything that deals with the video card is on that card, and it's loosely coupled, right? You plug it right in, right? So software engineering, you want to try and, you know, mirror those type of things on the real world. And then the art comes into it. Software is so loose and so flowing, right? When I try to explain to when I had my company, would explain to executives on why it's not so easy just to move code around. It's like building a house, even though code is so abstract and you can copy and paste, but it doesn't work that way, right? So if anybody here build a house, custom built home or anything, right? You get the blueprints, and then you sit down, and then you come in and you look at your home, and you're like, well, that's not really what I wanted, right? Can you move that wall back, or can you remove that wall and put it over here? Well, it appears on the surface that you can do that, but what you're not thinking about is there's wires and pipes and things that are underneath that you just, or support beams, right? You just can't move that wall. And software is a lot like that, right? Although we can move it very quickly, it can break things very fast, right? And then so the art side of it is kind of thinking around that. So you pull together these CS and engineering principles, and you start to think creatively, and how can I build on top of these principles and come up with my own ideas? And so I think we'll talk about here in a second. So writing code is a lot like writing fiction or writing papers. Has anybody written fiction in here? I know Alan has. Anybody try and write fiction, a short story? Yeah, yeah, poorly. I've written very poor fiction, believe me. But if it's very interesting to read about how you construct stories, right? And I think sometimes we mistake writing software where you sit down and you look at really good code, right? Let's say you look at a really good library, let's say the React framework, right? You go, oh wow, look at that code. It's so neatly formed together. It's really well written and tightly written. Well, I'm trying to think of, I can't remember anybody who wrote React, but right, they didn't sit down and just write that code down the first time, right? You sit down, you write the code, you start refactoring it, you're looking for abstractions, right? So there's two things in writing. You write and then you edit, and those are two parts of your brain. So you almost have to get into the subconscious of your brain, even when you write code, right? So you kind of look at, I'm gonna write my program from top to bottom. It's gonna be all slammed together. It's gonna be data access code, file access code, error logging, right? Poor handling of a lot of different things. And it's all just in one large file, right? And then you start finding abstractions and you start pulling those things out. And that's the editing phase, right? And once you edit a little bit, then you go back into the writing phase. Anybody here wear headphones? Noise canceling headphones? Anybody hear the flow, right? That's what you're doing, right? You're getting in the flow, you're blocking everything out so you can get a little bit into your subconscious, right? And junior programmers struggle a little bit with the grammar of the languages, right? And getting those into those subconscious, so then they can just flow out with code. And so the more and more you understand about your languages, your frameworks, it frees you up to be a little more creative, right? And so in coding, we call this coding and refactoring, right? So you code, you kind of step back, you refactor, you structure things, and you code a little more, right? And it's totally okay to check in, at least if you work with me, right? Check in PRs that are halfway done, that aren't totally complete, right? I do these interviews, these mock interviews for folks that are coming out of coding camps. And they're being trained to take these tests online where they're given a problem, they code, and then they hit the button and say, is this right? Well, it's not the way you code, right? No one ever writes like that, right? It's that you debug, you code, debug, test. Code, test, debug. Yeah, code, test, debug. Yeah, you write code, you test it, oh, you debug it, right? That's a constant cycle. Okay, so let's jump into some code. This is, I get set up here. I gotta put the readers on because I'm old. Is that showing up?
Yeah, maybe bump up the text.
Bump it up. A little better? Get all these out of the way here. One more?
One more. There we go.
Wow, is that the farthest I can go? Yo, what's up? No worries, you're all good. I couldn't resist, sorry. All right. Okay, so what we have here, that's loud, is a little Express code, Node code, right? Everybody's familiar, not Express code, this is just Node with using the HTTP module and the file system module, right? We're writing a little server. And this is gonna be a little bit of a contrived example, but I wanted to do something basic because it was gonna go fast, right? But you'll get the concepts, right? And so I'm gonna just read down this very fast, right? So we're creating a server, we're using callbacks. Everybody know what a callback is? Thank God. Not just promises and async await. All right, cool. Yeah, so we're using callbacks, good old school callbacks, right? And we're doing some really low level, tactical programming here, right? So we're looking at the request, and if, I think we have 2 of them here. Sorry for fast scrolling. Right, so if the URL is just into the root, we're gonna write out the header, and then we're gonna read a file in. We're gonna grab that data. If we get an error, we're gonna dump back some static strings to the console, to the stream. If not, we're gonna write that data out, right? Anybody spot any problems right off the bat, right? So, and let's run this. All right, so appears to be working. If we look here at the roots, we got pages index.html, and there it is. Just kind of that was our unit test right there. Just go look at the code. So that works. You know, if we start playing around, make sure that if I can spell student. Sorry. Is that good? Okay. So if I go to student, okay, and I got a 500 internal server error. Okay, something's going wrong, right? So if we set a little breakpoint and I refresh, and what am I doing here, right? I did code, so I did that ahead of time, right? But I'm testing it out, I'm gonna debug, right? So we're gonna go through that cycle. And I'm gonna step through, oh, we have an error, and then if we look at the error, okay, no such file directory. And I think I showed you a second ago, there's no student file here at all. All right, so we'll just throw that out, let that run, and then I think I put this in. I didn't hard code it. No, maybe I didn't. All right, so we're going to want to check if error. What was the message? Anybody remember what the error was? There was. No such file. So let's do. What does it includes? You guys are going to help. Is it includes, right? And I'll just do no such file. Yes. All right, and then let's do this, right? And so then we'll dump out of 404 and did I miss something?
That's a wrong square brackets instead of curly braces.
Oh, no. Pair programming at its funnest. All right. I always tell people this is the hardest part, right? Yeah. There we go. Let's restart this. Yep, just go. Cool, 404 not found, right? Okay, so that works. All right, now I have to go, oh, well, I'm gonna have to do that up here, right? I'm gonna have to do check for 404s there. If I start putting in more read files, right, I'm gonna, like, this isn't gonna scale, right? So we have tightly coupled code, right? We have file access code, we have HTTP listening code, we got error handling, returning messages code, right? It's all messed together. It's not highly cohesive, right? We have mixed modules in our system, and even and then it's tightly coupled with those modules are tightly coupled. And some of the smells for tightly coupled, right? You ever hear code smells? Yeah. So some of the code smells are hard-coded strings, configuration, huge files, right? A large number of lines within a function, I guess you should say, instead of huge files, right? So this is just bad, right? So I'll spare you from me kind of coding out some of the refactoring, right? To move to a more decoupled. But so let me just copy this and then I'll kind of run down the code. Right, so basically what I did is I created an RS helper, a response helper. And let's go into that real quick. Okay. Let's see what gets in there. Yes. Nope, don't close your eyes. All right, there it is. Okay, so yeah, so there's a response helper. And, you know, I just wrote some functions, right, that, and if you would have saw me code this out, right, I was thinking, it was like, oh, well, I'll use it to send data. And I was passing it. I was doing them, you know, very send success, send error, right? And it was all very one function each. And then I started refactoring them out, saying, oh, well, you know, I could do send found not found, send an error message, right? Which I don't have to pass in an error status and the full message, right? These are kind of in object-oriented. What is this called? Overloading of a function, right? Although we don't have that in JavaScript, it's just, you just name, you know. Yeah, so that cleans up the code a lot more. So now I still have file access, right? But I've taken out the handling of the files. I have a little library that will return error messages, right? And so if I need to change how my error messages are being written for all my 404s, I change it at one place, right? So now those are more highly cohesive, right? And we're starting to decouple things, right? And when we write these helper functions, right, well, what I don't like about this is I'm passing in the response, right? Or maybe you do. Anybody like this, or let's say Express with middleware, right? So when you fire up, well, not even middleware, but when you fire up Express, right, it'll put a .send on there, that .json, right? And it's, unless you know that, right, it's not super intuitive, right? So there could be an argument there that, yeah, passing in the response to a function is a little more obvious, right? Or not. I don't know. It's open to debate. And also, too, I didn't mention at the beginning of this, right? These aren't, you still have things that have to be coupled, right? There's still things that are coupled. Like in this instance, right? I'm still coupling the response object to how I send errors, right? It's just inherently coupled, right? The way you log to the system on disk, right, is through the file system, right? So those have to be coupled, right? But they can be loosely coupled, right? So does that make sense there? How we kind of refactored that out, and we could keep going, right? So we pull out the file system, we would take out all these strings, right? We would probably at something like when you fire up, you know, tell it where the static folder is, right? Or look for it, right? So you could do 404s and just not die on errors. Yeah, and then eventually you would get to something that looks like Express. And that's kind of the end point here, right? Where all of those things are kind of extracted away. Routing is extracted away. And it's very cleanly laid out for you. And this, of course, this isn't the full, complete example, right? But I hope that helps, right? It shows an example of, let me see if I have any more slides, but yeah, that's it. So we could go on and talk forever, right? How you refactor that more, basic principles, but those are the basic principles of all of your design patterns, right? So the facade pattern, they're the basic principles of C++, object-oriented programming, right? That's for you know, private variables, right? That's what all these things have come from, for these two basic things. So whether you're writing functional programming, procedural programming, object-oriented programming, systems design, right? These two principles are very core to all of those, right? So yeah, so I appreciate it. That's really been my talk. Follow me on Twitter and SoundCloud. I don't have a SoundCloud. That's it. Thank you so much.